Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, redox reaction. Come on, let us discuss few more questions from this session. And the mixture of sodium bicarbonate and sodium carbonate, volume of HCl required is X ml with the phenolphthalein indicator and Y ml with methyl orange indicator in the same titration. Hence, volume of complete reaction of Na to CO3. Okay, this is actually interesting question. Before going to solve, let us know some important points to note down. Here, colors of indicator in acidic and basic solution. So indicators, colors on acid side, colors on basic side, and pH at the color change. So methyl orange, red color in that pH, it is 3 to 5. So 3 to 5, it is a strong acid. So methyl orange used for strong acid and it is converted to basic, that is yellow. And the same way litmus paper, litmus solution, it is red color when it is in acidic solution, 5 to 8 and turn to blue. And phenolphthalein indicator colorless when you add in acid. So the pH it is 8 to 10. So 8 to 10, it is a weak acid, but it is a strong base pink color. So pink color, it is color changes when it is in basic side. Okay, I hope you got the clarity about this one. Still, I would like to give that idea about some more points. So please note down methyl orange used for strong acid, phenolphthalein used for weak acid. Okay, now methyl orange used for strong acid and weak base. The end point red to yellow for strong, that is used for strong acid and weak base. And the same way phenolphthalein indicator used for weak acid and strong base. Weak acid, what purpose I mentioned? Because 8 to 10, 1 to 7 it is acidic side, 7 to 14 it is a basic side. So 8 to 10 it is a weak acid side only. That is what. So phenolphthalein indicator we are using for weak acid. Right, now come to this point. Here colorless it can converted to pale pink. So phenolphthalein indicator actually first starting it is a colorless and converted to pale pink. Okay, now here Na2CO3 and NaHCO3. Na2CO3 it is a strong base. Right, when we are comparing with the Na2CO3 and NaHCO3, this is a weak base. You got it? So weak base and strong base. So weak base and strong base. Now you come to this point here, weak base and a strong base. So weak base where we are using, strong base where we are using. Okay, so this is a strong base. So strong base we are using phenolphthalein indicator. Okay, now what indicator we are using here? We are using phenolphthalein indicator for what it is, sodium carbonate and HCl. In the question it has mentioned mixture of Na2CO3 and NaHCO3. We are using phenolphthalein indicator and methyl orange. So phenolphthalein indicator we are using for strong base and weak acid, and the same way methyl orange indicator we are using for strong acid and weak base, strong acid and weak base. Now you see again, so here methyl orange, strong acid and weak base. I think you got the clarity. Okay, now come to this question. In the question XML and YML they mentioned, so Na2CO3 plus HCl, you are getting NaCl and NaHCO3. NaHCO3, that means sodium bicarbonate. It is not completely neutralized, though it has got salt. Usually acid and base, you'll get salt and water. But here what it is, carbonate, still it is available. Still half of the neutralization reaction yet to be done, right? So half of the neutralization reaction only it has done for 1 mole of HCl. So 1 mole of Na2CO3 plus 1 mole of HCl reacts in the presence of what it is, phenolphthalein indicator, NaCl and NaHCO3. We are getting right. Okay, now first and foremost, what purpose we are using phenolphthalein indicators? Generally, we are using indicators. See, suppose the reaction completed. So the reaction completed means how do we know? Indicating some indicators if we add, so the color changes. So color changes means reaction completed. So that is what that purpose only. What it is, we are using indicators. I hope you got that idea. So when you add phenolphthalein indicator to that acid, it is a colorless. When it is converted to pale pink, that means sodium carbonate and HCl completely dissolved and reacted. You are getting NaCl and NaHCO3. So you are getting pale pink. That is the reason the color changes. So that means that much of ml consumed for the reaction. I hope you got that idea. So this reaction Na2CO3 plus HCl, that reaction, it is half of the reaction only has been done. So next reaction, NaHCO3 again, NaHCO3 plus HCl, methyl orange indicator we are adding. So NaCl plus H2O plus CO2. So salt and water we are getting completely. So that means here complete reaction. See here I just mentioned complete Na2CO3 for what it is, half of the reaction, NaHCO3. NaHCO3, it is a complete reaction. Here I just mentioned here NaHCO3. NaH NaHCO3 for complete neutralization. So you will get here methyl orange. So methyl orange, what purpose we are using, and phenolphthalein indicator, what purpose we are using. I hope you got the clarity. So sodium carbonate means, now definitely that is a strong base. Sodium bicarbonate, even though it is a sodium is available, that is not comparatively, that is not strong base, that is a weak base. Okay, so where do we use methyl orange? Where do we use a phenolphthalein indicator? You got that idea. Okay, now this is XML. This is what it is, XML, and this is one more XML, right? So 2 moles we required. No, so that is what I just mentioned. So here what it is, 2 XML. Okay, so here actually for complete reaction, Na2CO3, for complete reaction, it is 2 XML. Okay, so first half of the neutralization, NaHCO3, it is a complete neutralization. So here one HCl and here one HCl, that means 2 HCl, 2 moles required. So that means it is 2x. I hope you got the clarity. Okay, NaHCO3 for reaction. This is Y, it has mentioned, no? So that means Y minus 2x. So Y minus x, Y minus 2x. So here y minus x. So total volume for both. So y is greater than 2x. So y is greater than 2x. I just to bring that. This is 1x and this is 1y. So that means this is more faster than this. That's what y is greater than 2x I just mentioned. So for complete neutralization of Na2CO3, we need 2 XML. 2 XML we required. 2 XML we required for what it is, to complete that reaction. So Na2CO3 plus HCl, NaHCO3 plus NaCl. So NaHCO3 plus HCl, you are getting sodium chloride, water, and carbon dioxide. So here 2x ml of HCl. Okay, now NaHCO3, y ml of HCl. So for NaOH, NaHCO3, you are getting y minus x. Now in the question, how many moles of HCl required for complete reaction? Complete reaction of Na2CO3, they are asking, right? Hence, volume of HCl for complete reaction of Na2CO3. So, Na2CO3, it has to be complete reaction takes place, means it has to be taken 2 points. First one, Na2CO3 converted to NaHCO3. Again, NaHCO3 converted to NaCl. So that means it has taken 2 XML, right? So 2 XML, they are asking Na2CO3 for complete reaction, 2 XML required. Suppose if they are asking NaHCO3 for this question, that will be the answer, y minus x, that is for NaHCO3. So they are asking about Na2CO3 for this answer, NaHCO3 for this option D answer. I hope you got the clear idea and you got that hint also. What purpose we are using methyl orange, what purpose we are using phenolphthalein indicator, how it has converted. Suppose any component they are giving in your hand, acid or base, how do we identify? We cannot touch and see, neither we cannot taste and see. So this is through indicators we can identify. So how do we identify? Methyl orange, if you put, means automatically converted to red. So that means we can see that is, we can say that is an acid component. And the same way, any compound, suppose if it is a basic solution, just you add methyl orange in that component, it will turn into yellow, right? Okay, now even ordinary tomato. So ordinary tomato juice, you just take in that, tomato juice is red in color only. Okay, lemon juice, you take lemon juice, in that methyl orange you add, you observe what it is happening. These are all logical way thinking, but harmless. You have to use it when you are going to that lab. You have to be very careful, but harmless way you can test lemon juice, nothing will happen. This is citric acid, so easily you can identify. And the same way, phenolphthalein indicator you add, it will not change the color. After adding phenolphthalein or methyl orange, don't go for taste and all. Okay, so generally when you are going to that lab, chemical lab only, you have to use mask. Okay, because all the chemicals are there, definitely it will what to say, evaporate, explode. So you have to be very careful. So whenever you're going to the lab, you have to be very careful. Of course, your teachers or professors will say that you have to be very careful. They'll have that awareness and they will give so many guidelines for you when you enter into that lab. Okay, fine, come on, let us go to the next question. I hope you got the clarity about this question. Come on, let us go to the next question. The next question, 0.1 gram of a solution containing Na2CO3 and NaHCO3 requires 10 ml of 0.01 N HCl for neutralization using phenolphthalein as an indicator. Mass percentage of Na2CO3 solution. See, last question also we have seen such kind of related questions only. Now, first and foremost, Na2CO3, right? Now, Na2CO3 combined with the HCl, you will get what it is, NaHCO3 plus NaCl. Okay, now this is a strong base, right? So this is a strong base. We use phenolphthalein indicator. Phenolphthalein indicator, actually what it is, the pH point, it is 8 to 10, right? Okay, now this again, NaHCO3 combined with the HCl, you will be getting what it is, NaCl plus H2O plus CO2, right? CO2, right? Okay, now here 0.1 gram of the solution containing Na2CO3 and NaHCO3 requires 10 ml of 0.1 N HCl. Now here, as we observe this point, here 1 mole of Na2CO3, 1 mole of HCl. So here, what it is, moles ratio, it is 1 mole of Na2CO3 and 1 mole of HCl. So here, let us write the data so that it will be easy for us to identify. Now here, data as we observe, here volume of HCl. Volume of HCl, how much? 10 ml. So 10 ml we converted into liter, it is 0.01 liter, right? You remember. Now next one here, normality of HCl. So normality of HCl 0.01 N they mentioned. Now moles of HCl equal to normality into volume in liter. So here 0.1 N into 0.01 liter. So how much we are gaining? So we are gaining by 0.0001 what it is, moles. Okay. So we can mention 1 into 10 to the power of minus 4 moles. Can we write it in that way? Okay, so that is moles of HCl. Now here moles of HCl we found, that is 1 into 10 to the power of minus 4 moles. Right now we are going to see what it is. Moles of Na2CO3. In the balanced equation, 1 mole of HCl, 1 mole of HCl is equal to 1 mole of Na2CO3 in the balanced equation. That is what we have gone through, right? Okay, and the same way, so here now moles, number of moles of HCl according to this data here 0. That is 0 instead of that 1 into 10 to the power of minus 4 moles, right? So that means number of moles of HCl is this. So that means number of moles of Na2CO3. So Na2CO3 also it will be same only, right? Okay, and 1 into 10 to the power of minus 4. Okay, now let us identify the given mass. Then only we can go for to find the percentage of that. So here, what it is, number of moles, that is number of moles of Na2CO3 equal to what it is, given mass by molecular mass. So given mass, actually what it is, given mass, we don't know, that only we have to find out. And the number of moles we know, just now we found these both are equal. So that means given mass equal to, so given mass of Na2CO3. Given mass, if we know only, we can find out what it is. Number of moles, already number of moles we got it, that is both are equal. So that means here number of moles into molecular mass. Can we go in that way to find that number of what it is, given mass? Okay, so that means here number of moles, how much? 1 into 10 to the power of minus 4 mole into molecular mass of Na2CO3, it is 106 gram per mole. You know very well, right? So 106 gram per mole, right? Gram per mole. So what is the answer you will be getting? You will be getting 0.0106 gram, right? So this is given mass, right? So given mass means it's a gram. Now percentage mass, we go for it. So percentage mass of Na2CO3. So percentage mass of Na2CO3, that is given mass divided by what it is in the question, what it is, total sample. Okay, total sample mass, right? So that means here they have given what into percentage, no, into 100. So you'll be getting what it is, given mass, how much? 0.0106 gram divided by total mass of the sample, or how much they have given, 0.1 gram. So you'll be into 100, right? You'll be getting what it is, you'll be getting 10.6 gram. That is 10.6 percentage. Okay, 10.6 percentage will be getting. I hope you got the clarity. How do we go for it? And methyl orange, how to use, methyl orange, where to use, phenolphthalein indicator, where to use, you know very well. So phenolphthalein indicator, it is used for strong base and weak acid. Methyl orange, we can use it for weak base and strong acid. I think you got a very good clarity about this point. Okay, as I mentioned here only, this is strong base for Na2CO3. This is a strong base of phenolphthalein indicator. And the same way, this is weak base. So we can use methyl orange. So here, just to remember that sake, I just mentioned. So which is the correct option? Option, actually they did not give any option, 10.6% only, but they did not give any of the option. So this none of these only is the correct. So actually, what is the answer for this? 10.6 is the correct answer option. So it is not there, means option D, none of these. I hope you got the clarity and indicators, what purpose we are using, and the phenolphthalein indicator also. You just believe that indicator, phenolphthalein indicator used for what it is? pH level, it is 8 to 10. So 8 to 10, it is a strong base only, no. So 7 to 14, it is a strong base. Of course, 8 to 10, it is a strong base only. So strong base and weak acid. Yes, come on, let's go to the next question. A mixture of NaOH and Na2CO3 required 25 ml of 0.1 M HCl using phenolphthalein as an indicator. However, the same amount of the mixture required 30 ml of 0.1 M HCl when methyl orange was used as the indicator. Molar ratio of NaOH and Na2CO3. Right. Now here, when we are using phenolphthalein as an indicator, so here NaOH plus Na2CO3. Right. These both are mixture combined with 25 ml of 0.1 M HCl. Right. And the same way here methyl orange used as an indicator. So here what it is? The same amount, NaOH plus Na2CO3. Here 30 ml, right? 30 ml of 0.1 M HCl. Now you see the difference here. Here 25 ml and the same amount, here 30 ml on the same amount. But what it is, which is different? Methyl orange and phenolphthalein indicator, both are different. So methyl orange and phenolphthalein indicator, here strong base and weak acid. That is what first question only I have given the clarity for you to understand. Here pH, it is what it is, 8 to 10, right? And the same way methyl orange indicator, what it is, weak base and strong acid. pH, what it is here, 3 to 5. So that means it is a strong acid, right? So strong acid. Okay, now let us find the molar ratio. Now this is the question. Right now let us find the molar ratio. So here what it is, let us check with that X plus Y. Right, these both are X plus Y equal to N mole. Right, N mole of HCl equal to 25 ml into 0.1 M, that whatever they have given in the data, no, so you will be getting what it is, N mole of HCl. So what is the mole of HCl? You will be getting 2.5 M mole. What it is M mole? Because here mentioned milli ml, no, ml, no, so that is millimole. And the same way here X plus 2Y equal to N mole of HCl. It is actually what it is, 30 ml into 0.1 M. Right. So what is the answer you will be getting? 3.0 M mole. Right. Now here the first one, it is phenolphthalein indicator. The second one, it is methyl orange indicator. So methyl orange indicator, weak base and strong acid, and phenolphthalein indicator, strong base and weak acid. So here X plus Y, for methyl orange it is X plus 2Y. I think 2, you got that idea? 2 moles of HCl required to complete the reaction, right? Okay, even in the last question, first question also we observed, this is the last question, and even in the first question we have got that idea. How do we go for it? You just observe that point. Okay, now next one here in this, now solve this X and Y. Okay, how to solve? Now this is the first equation, and this is the second equation. So equation 1 and 2, so we can subtract equation 2 to equation 1. So equation 2 to equation 1 now, so that we will come to know that idea. So here what it is, X plus 2Y minus X plus Y equal to 3.0 minus 2.5. So you will be getting Y equal to 0.5. Yes, you got it now. So X, so we can apply the value in equation 1. So X plus Y, so that means X plus 0.5, Y only 0.5, no, X plus 0.5 equal to what it is? I just bring X plus Y equal to 2.5 M mole. Right, so X plus Y equal to 2.5 M mole. So you'll be getting what it is. So X equal to 2.5 minus 0.5. So you will be getting what it is, X equal to what it is, 2.0 M mole. So X also you got it, Y also you got it. This is X and this is Y. I hope you got that idea. Okay, now next one, molar ratio, let us identify. So what is the molar ratio? So molar ratio of NaHCO3 and NaOH. So NaHCO3 and NaOH. So you'll be getting what it is. So X by Y. Go for it. So 2.0 divided by 0.5. X value is 2.0 and Y value it is 0.5. So you'll be getting what it is, 4 by 1. So the molar ratio of NaOH. So molar ratio, this is X now phenolphthalein indicator and this is Y for methyl orange indicator. Okay, so the molar ratio, the molar ratio of NaOH to Na2CO3. So you'll be getting, that is actually a mixture. These both are mixture now. This is actually what it is, 4:1. So let us check the value here. What is the answer? I hope you got that clarity. How do we find that? Yes, and indicators. See, all these questions are based on indicator. How do we use? What is the pH value? That's what first starting only I think I have given. Yeah, now which is the correct option? Option C is the correct option. C is the correct option. I hope you got the clarity. Come on, let's go to the next question. Next question, when 100 ml of solution sodium hydroxide and sodium carbonate was first titrated with N by 10 HCl in the presence of phenolphthalein indicator 17.5 ml were used till the end point is obtained. After this end point, methyl orange was added and 2.5 ml, the same HCl were required to attain the end point. Now, amount of NaOH. Amount of NaOH, here it is actually given mass of NaOH they are asking in the question. Right now, come on, let us check. So here, what are the mixture of the solution? NaOH plus Na2CO3. This is the mixture of the solution. This is the mixture of the solution, right? So in that mixture of the solution, what we are using? N by 10 HCl. N by 10 HCl we are using. Okay, so with the use of what it is, phenolphthalein indicator, how much HCl required, volume of HCl required, it is 17.5 ml required. And the same point here, sodium hydroxide with HCl, here methyl orange, here methyl orange indicator we are using. How much it has taken? That is volume of HCl. It is 2.5 ml of HCl. HCl only. So to complete the titration, so volume of HCl, this is we can take it as a V1, right? And this one we can take it as a V2, right? So when we are using phenolphthalein indicator, in the presence of phenolphthalein indicator, HCl is titrated against that mixture of basic solution. So this is actually what is it? Strong base and weak acid. For what purpose we are using? That is for the phenolphthalein. And the same way, methyl orange, what purpose we are using? Weak base and strong acid, that you know very well. Right now, volume of HCl, you might have known very well. This point, 17.5 ml for that phenolphthalein indicator, 2.5 ml for that methyl orange indicator. Now, that volume of HCl completely got over. Now, volume of NaOH, how much it has required, that we have to identify. Because both are same solution only, like both, after finishing this reaction, now we are going for the second methyl orange. So this is V1 minus V2. We can go for in that way, no? So V1 minus V2 means 17.5 ml minus 2.5 ml. So that means you will be getting what it is, around 15 ml. 15 ml of NaOH required to complete the reaction for both. Okay, so that is a mixture of the solution. No? So first one we are using what it is, 17.5 ml of HCl titrated against with sodium hydroxide and sodium carbonate. That is for phenolphthalein indicator. Yes, over. Now, after finishing that end point, we are adding methyl orange. Again, we are titrating in the same solution to get that end point. So, volume of NaOH. So, how much of the volume required to complete the reaction? 15 ml. I hope you got that idea. Yes. Now, we have to find out that given mass of what it is, given mass of NaOH. So how to find out the given mass of NaOH? So normality into volume of solution in liter, usually we'll go for liter only, and into equivalent mass. Equivalent mass is what it is? Equivalent mass actually molecular mass by N factor, that is equivalent mass, right? So this is actually what it is? Molecular mass by N factor. So N factor, it is sodium hydroxide, it is only 1. So molecular mass, it is what it is? 40 by 1. Got it? Okay. Now let us apply the value. So here N by 10. No, N by 10 means what it is? Here 0.1. Okay. So 0.1 NaHCl into volume of solution of sodium hydroxide. It is 15 ml. No, in liter 0.015 liter. Okay. We consider as a liter only. Into equivalent mass. It is 40 by 1. No, 40 only. So you will be getting around what it is? 0.1 N, 0.1 N into 0.015 into 40. So you'll be getting 0.06 gram. So that is the given mass of sodium hydroxide. Okay, I hope you got the clarity. How do we identify? Very easily, I think you got an idea. And you are thorough for that phenolphthalein, what purpose we are using, and the methyl orange, what purpose we are using. Again, I'm mentioning phenolphthalein we are using for strong base and weak acid, and methyl orange we are using for weak base and strong acid. Okay, now come on. Yes, as we observe this option, we have calculated for liter only, but they have given for 100 ml, because in that 100 ml only. Suppose in that way question goes means, so here 0.1 according to that formula, normality into volume of the solution into molecular, what it is, equivalent mass, 0.1 into 15 ml into what it is, 40. If we are going in that way, here you will get 60 gram. Here 60 gram, right? So when you calculate this, you will get 60 gram. So here in the option, they are asking per ml. So 100 ml, 0.06 gram. Here we got that answer here, what it is, 0.06, right? 0.06 gram. So per 100 ml, it is 0. For liter, this is actually what it is. This is ml, but here per ml they mentioned, right? So when we are going in that way, this is the correct option. So which is the correct option? 0.06 gram per 100 ml, right? Per 100 ml, 0.06 gram, we are using sodium hydroxide, the given amount. Yes, come on, let's go to the next question. Question: 1 gram of a sample of calcium carbonate was strongly heated and the carbon dioxide liberated was absorbed in 100 ml of 0.5 m NaOH solution. Assuming 90% purity of the sample, how many ml of 0.5 m HCl would be required to react with the resulting solution to reach the end point in the presence of phenolphthalein indicator? Right. Now here in the sample, calcium carbonate is the sample, right? Calcium carbonate is the sample. Here percentage purity, what they have given, 90%. So 90% purity they have given. Okay, now here when we go for this reaction, while heating, strongly heating, so we will get what it is, CaO plus CO2. So carbon dioxide liberated, they mentioned very clearly, right? So liberated was absorbed in 100 ml of sodium hydroxide solution. So this carbon dioxide, which is absorbed by 0.5 m sodium hydroxide solution, right? Okay, assuming 90% of purity of the sample, right? Okay, now here mass of pure is in CaCO3. Okay, mass of pure CaCO3. So here what it is, 1 gram they mentioned. No, purity it is 90%. So 1 gram. So mass percentage, 1 gram into what it is, 90% means it's 0.90. So you will be getting 0.9 gram. It is mass. Right. Okay. So mass of calcium carbonate, we got it. Okay. Now mass, we got it. Now moles we have to identify. So what is the moles of, so given mass by molecular mass. Okay. Moles of CaCO3. So CaCO3 given mass by molecular mass. Right. So here 0.9 divided by CaCO3, it is 100. Well known, gram per mole. CaCO3, it is 100 gram per mole. It is a special century, right? So centum, right? So usually we'll ask the students how much you will get that marks in the chemistry, means they will say here mass of calcium carbonate, molecular mass of calcium carbonate, they will say. Right, now molecular mass of calcium carbonate is 100, right? Okay, that is what purposely they will say. Okay, those are very well versed in chemistry persons, chemistry students, right? Okay, now come to this point here, 0.00 mole, 0.009 mole, as we are talking here, this also. Okay, now fine. Now next one, here moles of carbon dioxide, moles of carbon dioxide liberated, that is also we have to identify. Moles of calcium carbonate we found. So I just mentioned here, moles of calcium carbonate here, 0.009 mole. Right, next one, what it is, moles of carbon dioxide liberated. So moles of carbon dioxide liberated, moles of carbon dioxide liberated, how much it is? Actually this is also same, this moles of calcium carbonate, moles of calcium carbon dioxide. Now you come to this point here, question here, what it is, in that here it has mentioned very clearly here what it is. In this point I'll go. So here 1 mole, here carbon dioxide also 1 mole, that is what, right, 1 mole and 1 mole. So this mole is equal to this mole. So here also moles of carbon dioxide 0.009 moles, both are equal, right? Okay, now ratio of these CaCO3 and CO2 Right, 1:1. Got it? Okay, now liberated carbon dioxide, it is absorbed by 100 ml of sodium hydroxide. That is liberated, that is arrow marker, liberated carbon dioxide, which is absorbed by what it is 0.5 m of, that is molarity of sodium hydroxide. So come on, let us check the equation here. So here that is 0.5, what it is, CO2 plus NaOH. So here NaOH, you will be getting what it is, Na2CO3 plus H2O. So Na2, no, here you will get 2. So here 2 and carbon dioxide CaCO3 and H2O. Yes, you got it. So initial moles of NaOH. Right, this is the reaction. So the liberated carbon dioxide, which is absorbed by 5 molarity, that is concentration of sodium hydroxide. So now we are coming to that initial moles of sodium hydroxide. That means before the reaction it is 0.5, right? So here 0.1, that is the concentration, right? 0.1 liter into 0.5 m, right? So 0.05 mole. So initial moles of NaOH. In the question it has mentioned no volume of the solution. Volume of the solution, how much they mention here? 100 ml of no. So that is what, 0.1 liter it has mentioned. Right, I hope you got that idea. Volume into molarity, number of moles equal to volume into molarity. Generally, molarity equal to number of moles of the solute divided by volume of solution in liter. So here moles of that point we are asking. No, so moles means here liter, volume of the solution into molarity. So we'll get that moles. So initial, now moles of sodium hydroxide after consume, moles of sodium hydroxide after reaction or after consume, like this equation, no, after consume. So how much it is moles we have to consider, right? So here 2 moles of sodium hydroxide, no, so 2 moles of sodium hydroxide into next one, what it is, sodium hydroxide and carbon dioxide. Moles of carbon dioxide, what it is, 0.009 mole. Right, so here moles of carbon dioxide and moles of sodium hydroxide. Here 2 moles of sodium hydroxide reacts with what it is, 0.009 moles of carbon dioxide, because from there only it consumes, that means it is absorbed, right? Okay, so you will be getting 0.018 mole. Got it now? Now remaining, so this much it has consumed, so remaining moles of NaOH remaining. So remaining moles of NaOH. Remaining moles of NaOH, how much? Here, remaining moles of NaOH, this is mole, no? So this is 0.5. 0.5 minus 0. How much consumed? 0.018 mole. Right, now you'll be getting how much? 0.032 mole. Right, moles of Na2CO3. Now final point, moles of that product, no? So moles of Na2CO3, very long thing, na? So advanced questions you will get such kind of. Okay, moles of Na2CO3. So you will get what it is, 0.009 mole. Right, in the question also it is, I mean starting only we have mentioned, no, Na2CO3. See here 0.009, right? 0.009 mole we got it, no? And resulting solution contains, now we are finding that resulting solution contains. Okay, so resulting solution contains what it is, 0.032 mole of free NaOH. That means here we consumed this much, it is a mole, and it is consumed, this is a remaining, no? So remaining means free NaOH, and 0.009 mole of Na2CO3, right? Now Na2CO3 plus HCl, Na2CO3 plus HCl. See how many reactions it has taken place. See, all like puzzle. NaHCO3 plus NaCl, right? Okay, so HCl required how much of ml? HCl, that is the question, right? HCl required for the reaction, how much ml? So this is 0. Before finding that volume, we have to find the mole, no? So this is 0.009 mole, right? Okay, total moles of HCl required. Total moles of HCl required, that is 0.032 plus 0.009 equal to 0.041 mole. You got it? So this much it is required. So now we are coming to that final point here, volume of NaOH. Here what it is, volume of volume of 0.5 m HCl. So volume equal to what it is, number of moles into molarity. So number of moles divided by molarity. Volume of solution is equal to number of moles by molarity. See, generally number of moles equal to volume. Now what it is, number of moles of solute divided by volume of solution in liter. Now volume of solution is upwards. Now volume of solution is equal to number of moles by molarity, that exchanging. Right now here 0.041 mole for 1 mole divided by 0.5 molarity. So you will be getting what it is, 0.082 liter, right? So here volume in ml, volume in ml. Yeah, volume in ml means here 0.082, no? So 82 ml, right? I hope you got the clarity. Right now here in this point 0.41, how do we get it? 0.041, it is a number of moles which is required. So these both we are calculating. So these both are what it is, 0.032, what it is, 0.032, it is a free remaining, and number of moles of sodium carbonate. So these both, if you add, no, so you'll be getting total moles of HCl required, we will be getting. I hope you got the clarity about these two resulting of solution contains free of NaOH and free of Na2CO3. When we add, see all this, finally we are coming to that result. It's a very long procedure and process. I hope you got that idea. And you know, this is actually what it is, HCl required to reach the phenolphthalein as the indicator. Okay, now come on, I'm asking this question. Phenolphthalein indicator used for what purpose? It is a, what it is, can you tell me? Yes, I can hear your voice. Yes, strong base and weak acid, right? Strong base and weak acid, no? So that only find used for that 82 ml of 0.5 m HCl required to reach that phenolphthalein indicator. 82 ml. Right now, what is the correct option? So here, see, very big. 82 ml. Yes, you got it. So HCl would be required to react with that resulting solution to reach the end point. It is what it is. Phenolphthalein indicator 82 ml. HCl required, right? 82 ml is the correct option. Option C is the correct option. I hope you got the clarity of all these questions. And yes, thank you for watching. And next video in our next question in our next video. Till then, thank you.